Hey everyone, welcome back to the channel. Welcome back to another video, and thanks so much for joining me in another step in our tech journey. And again, this is going to be a video focused on tech, and specifically I wanted to make a video about learning how networking works from an IP level. So in today's video, we're going to go over IPv4 addressing, and you're going to learn all there is to know about it. Now there's a few things that we're going to cover. So again, I mentioned IPv4, how to calculate that and understand what that looks like. We're going to understand what a subnet mask is and a prefix. And also as well, you're going to learn about what a default gateway is and how it all ties in together to complete this picture that we call IPv4 addressing. So as always, guys, if my channel helps you out a lot, go ahead and give me a like for the video as it helps the channel grow. Make sure you subscribe to the channel and turn on your notifications so that way you're notified when I upload new videos to the channel. And of course, share this with a family member or friend who's interested in learning. Also as well, guys, I'm going to put links in the description for my previous videos, especially in the tech series, because we're going to build on concepts that I've covered in the past. So if this is your first time finding me, go ahead and watch some of those videos as we're going to build on those concepts, and then you can come back to this one so that way you're not confused. Oh, and I almost forgot, guys, if you are interested in talking with me about tech, I'll also leave links in the comments section below so that way you can book time on my calendar. So housekeeping aside, guys, let's head to the desktop and let's go and learn all about IPv4 addressing. Hey everyone, welcome to the desktop, and of course the next lesson that we are going to tackle, and that is IPv addressing, and specifically IPv4. Now we'll talk about IPv6 at a later video, but strictly for this video we're just going to focus on IPv4, how it even works, what is it all about, right? Because it's very, very interesting. If you've never seen IP addressing, you don't know exactly how it works. It's a little confusing, but I will do my best to make it as easy and as simple as possible for you. Now, before we get started, real quick, I will say there are some other videos that I have in my playlist as far as how the internet works, how it works like the post office, or for example, the core internet devices. So if you haven't seen some of those videos, I typically build on those topics. So go check those out. And if you have any questions, of course, you could always leave me a comment. But once you're done watching those videos, you can come back to this one because we are building on those concepts that we went over. Without further ado, let's jump into IPv4 and specifically what is it, and how do we figure this stuff out? Because when I was first learning about this, it was a little difficult, but I think it just takes a good teacher in order to teach you exactly how it works. So buckle up here. Now, the first thing you say to yourself is, okay, we learned in previous videos that you need an IP address in order to talk to people, right? In order to take your information and send it out over the internet. Now, I have multiple computers in my home, and of course, each of them has their own IP address. Real quickly, let's take a look at how we find our IP addresses for multiple systems, and we can kind of have an understanding of what it is, and we'll break it down. So first things first, the computer that you're seeing here is actually a Windows 11 machine, and I'm running a open board application on here in order to teach you guys. But how do we find the IPv4 address for a Windows 11 machine? Well, if we bring up our taskbar here, we can go to Windows, and I can just go ahead and type in Control Panel. So we bring up our control panel here. So let me bring that into the picture. And the area that you want to click on is called the Network and Sharing Center. And here's where you click and figure out everything that is associated from a networking perspective on your Windows machine. And specifically the one that I am going to concern myself with is Ethernet 2. Now yours may be a little bit different, but of course you can probably find your Ethernet or you can find your Wi-Fi, and it's in this particular screen. So let's go ahead and click on our Ethernet 2 here, and I am going to bring in our screen here. And as you can see here, as I mentioned, I have a 10 gig connection back to my router, which is amazing. I love to be able to, send information very quickly. And you can actually see right now that I am sending and receiving data. But more importantly, if we click on this details option here, this is where you start to see all kinds of information about your computer, and especially from a networking perspective. So the one that I'm very interested in, and of course I will blur some of this stuff out so that way you guys can't see my MAC address. Remember, that's very important. And if you don't know what a MAC address is, go watch my other videos and I explain to you what that is. What I am concerned with is what I just highlighted here in blue, and that is my IPv4 address. Now, the other thing too that is also very important is an IPv4 subnet mask. And we'll talk about what a subnet mask is, what an IPv4 address is, and the last thing that I will say that is also very important, and three things that we're going to talk about today when it comes to IPv4 is your IPv4 default gateway. And that is this one that I have listed out over here. So remember, the three things that are very, very important are your IPv4 address, your IPv4 subnet mask, and your IPv4 default gateway. Those three items are very important. All right, so we saw IPv4 from a Windows perspective. Let's head over to the Linux side now, and let's take a look at a Linux machine and how we grab that. And you can see what the IPv4 address is for the Linux side. So here's my Linux machine that is running. I do have my terminal up. And so if I were to type in the command nmcli and hit enter. So if we take a look at the first interface here, and the first interface basically says EMP0S3. That is the name of my interface. Now in that interface, it does tell me my IPv4 address. So if we take a look here, this is my IPv4 address, but it's interesting because it has a /24 on there. What does that mean? And we'll tackle that in just a few minutes. But just know that this is my IPv4 address. Also as well, the other thing that we need to concern ourselves with is our IPv4 gateway. Now you can see that our IPv4 gateway is listed right over here. All right, guys, so let's take a look at this IPv4 and break everything down. And here on our screen, you're seeing a screenshot of the IPv4 address that I had for my Windows box, along with the subnet mask, and also as well the IPv4 default gateway. I'm not going to touch on what the DHCP server or the DNS server is in this particular video, but we'll touch on that in another video, so stay tuned to the channel. And I think the biggest thing that we can see here is that we have an IPv4 address of 192.168.1.49. That's the IPv4 address. And so if we take a look and we break this down and we say, okay, well, what is this? How does it work? So when we look at computers, computers have what's called an on or an off switch, a 0 or a 1, or what we call binary. That's the only two states that a computer can ever be. So let's go ahead and say 0 or a 1. Right, so how do we get a 0 or a 1 and somehow we translate that into what we see at the top over here, which is 192.168.1.49. Let's go ahead and make some space here. Let's go ahead and clear this 0 and a 1. Now, in order to take what you just learned, which is the basic foundations of computers, is just a 0 or a 1, an on or an off, how do we basically get this number out of this 0 or a 1? And then we start building on what is called binary math. So if we take a look at this and we say to ourselves, okay, well, how do we get this 192.168.149? We have to break this up in groups. So for example, this is the first group, this is the second group, this is the third group, and lastly, this is the fourth group. If we were to do 1, 2, 3, 4, this is another reason why we call it IPv4. Not necessarily, but I thought it was very cool and very interesting. When we take a look at this now and we say to ourselves, okay, well, how do we get a 49? How do we get a 1? How do we get a 168? And how do we get a 192? So if you didn't know, IPv4 addresses are what we call 32-bit addresses. Go ahead and write that here, 32 bits. Now, what is a 32-bit address? So if we take a look at, let's just say this first group over here, which is the 49, how do we get 32 bits? So essentially what I'm saying is you have 8 bits. So we can put bits here. You have 8 bits in the next group, and then you can have 8 here, and then lastly, of course, you can have 8 here. So as you see, there's 8 bits in the first group, 8 bits in the second group, 8 bits in the third, and of course, 8 bits in the fourth. So as we take a look at this now, we say to ourselves, okay, well, cool, you can have 8 bits, and remember, when I say bits, what does that mean? That means either a 0 or a 1. So if we want to make this a little bit easier, let's say if I were to say 8 bits, 0, 0, 0, there's 3, 4, 5, 6, 7, 1, 8. Or you could have all zeros, you could have all ones, but the point is, all of these together is equal to 8 bits. Now you understand what a bit is. Basically, it's a 1 or a 0. 8 of them together make 1 octet, is what you'll commonly hear it referred to as. And an octet is a total of 8 bits. And now you have 4 of them. So 4 of them gives you a total of 32 bits. Okay, we're building here now. So how do we turn that 49 now into 8 bits? Well, now this is where you're going to take the power of binary math. And for those who don't know, computers run on what is called binary. So I'll put it right here. Binary math. So binary math is what allows us to translate that 49 that you see there in the first group into a 0 and 1 combination for a total of 8 bits. How do you go ahead and do that? Well, now you're starting to get into what is called, again, binary math, and it's 2 to the power of something, 2 to the power of x. So in our particular case here, and to make things very simple for you guys, I'm actually going to teach you how to cheat a little bit here. And when I say cheat is we're going to use a calculator. And most people don't know this, but the calculator actually is a built-in calculator into pretty much every single operating system. And you can figure out how to translate from binary to decimal. So for example, decimal is the numbers that we see every day. So when we count 1, 2, 3, 4, 5, so on and so forth, that is decimal. But in the computer world, they don't operate in decimal, right? Computers only understand ones and zeros, on or off. So you have to translate the decimal number that you see here into what's called a binary number. And you can use a calculator in order to do that. And by the way, if you guys are interested in how to do binary math, I can show you in another video how that all works. So just leave me a comment in the comment section below. So if I were to go ahead and take a calculator, and I'll bring it into the screen here for you guys, that way you guys can see. So now that we have our calculator up, and of course I'm going to block the networking screenshot there for a second, just to show you guys how the calculator is going to translate everything for us. But if I were to take a look at that 49 there, which is a decimal number, and I want to turn it into binary, which is what the computer understands, I can go, instead of the standard, and remember this is on a Windows 11 machine, but I can go into the standard section here, click the little hamburger bar, and I want to go into programmer. Now you have hexadecimal, decimal, octal, or binary, right? So I'm going to go in decimal, and I'm going to put the number 49 here. And instantly the computer, or should I say the calculator, will translate that into a binary number for us. Now, keep in mind that we are only interested in the first 8 bits. Sometimes a computer can actually give you more than 8 bits, but you're only concerned with the first 8 because, again, that is what makes the first group. That's why they call it octal. You're interested in only the first 8 bits. And the first 8 bits are read from right to left. So if we take a look here, it actually gives us exactly 8 bits. And the translation from that from right to left on the calculator is 1 0 0 0 1 1 0 0. And that is number 49. So I'm going to go ahead and take the first group here, and I'm going to write 1 0 0 0 1 1 0 0. So if we were to wrap this up now and we say this is the first group, this group here, group number 1, that is equal to number 49. So let's put a dot here because of course this is an IPv4 and we have our first 8 bits, again, from right to left. So now we're concerned with group number 2, and group number 2 is a 1. And by the way, if you don't know, we actually did a 1 right up here. And for those of you who don't know, you can actually take those numbers, write it in the calculator, and actually go ahead and convert it back to a decimal so you can see that. So real quickly, if I were to bring in our programmer calculator back into the screen here, you can see that if I were to take this binary number and click binary here and just erase all of this, let's just put a 1 here. And the rest of them are zeros, so we have no real need to fill them in, of course, right? So we can just leave it as is, and you can see here that decimal 1 is equal to 0, 0, right? 3 zeros and then a 1. Now, if you're saying to me, hey, I need a total of 8 bits, but I only have 4 here as you're seeing, well, go ahead and fill in the rest with zeros because that's going to equal to a 0. And again, this all has to do with binary math, so I'll show you this in a later video if you're interested. But if you fill in the rest of the zeros here and you have a total of 8 bits with the last one here being 1, you can see, of course, that it equals 1. Let's go ahead and we are going to fill in the second group here. 1, 0, 0, 1, 2, 3, 4. All right, so this now is our second group, and this is equal to 1. Now let's put a dot here, and let's work on our third group. So our third group is 168. So again, one of the easiest ways to do this is you can go ahead and take 168 and put it in the calculator and have it converted for you. So we're going to bring in the calculator. Let's clear this. 168. And you can see here that from left to right on the calculator, it's 10101000. Or again, you can read it from right to left, 00010101. That is 168 in decimal. So let's go ahead and write that down. So there you go. From right to left, you have 00010101. And that is group 3. And so group 3 is going to equal 168. Now we're going to work on the last group, and the last group is going to be 192. So if I were to take, again, my calculator, bring it into the screen here, let's go ahead and clear this. Let's put in decimal 192. You can see that the binary equivalent is from left to right, 1, 1, and the rest are zeros. Or from right to left, you can see that all of them are zeros except till you get to the last two, which is 1, 1. And by the way, since I'm running out of space here, I'll probably put group 4 under group 3. 1, 1, 0, 0, 1, 2, 3, 4. So there you have it. You have 1, 1, 0, 0, 0, 0, 0, 0. That is equal to 192. And we're going to put a little dot here. And then this, of course, can go right up here. So now we have the full IPv4 translated. So remember, IPv4 is 32 bits in total, and it can be a 1 or a 0. You put them all together, and they equal some type of number. And they also show you a lot of information that most people don't even realize. For example, they can show you what the network is, and they can show you how many hosts you have in your network. So at a minimum now, you actually understand how to take these decimal numbers and translate them into what the computer understands, which is binary numbers. And again, as I mentioned, they're broken out into 4 different groups for a total of 32 bits, and that is what is considered an IPv4 address. So we just looked at IPv4, and you now know what the address is. Again, let's move on to IPv4 subnet mask. And the IPv4 subnet mask is interesting. It says here 255.255.255.0. Well, what does that mean? Now, guys, whenever you're working with networking, and especially on computers, your subnet mask actually tells you what your network is, and it also tells you how many hosts you have in your network. So think about, for example, right, when I have a network, and we can do a little cloud here for a network. In this little cloud that we have here, we have computer 1, computer 2, and this is going to be equal to my network. Well, within that network, how do you know what is the address for this particular network? And then once you access that particular network, how do you know what computer, let's say, for example, we continue this, computer 3, how do you know what computer you want to target within that particular network? And again, guys, the subnet mask is what tells you all this. So let's break this down a little further so you can see what I'm saying. So if I were to take this subnet mask, as you guys are seeing here, and I were to take it and break it up, this first part here tells you the network itself. And then this part here tells you how many hosts within inside of the network. So as an example, we can say network, and then you have hosts. So let's break this down. And just similar to how we did with the IPv4 address, we can break down the network mask and also as well see how all of this relates. If we were to write this again, let's say 255.255.0. Now, what is decimal 255 in binary? And you guessed it, we're gonna make life simple and bring up our calculator here because we're not gonna take a guess. So we're gonna go ahead and clear. Let's go to decimal. Let's put in 255. And what do you know? In binary, it is all ones and especially 8 bits. So that is pretty cool. All 8 of them are 1. So now I'm going to take this and let's go ahead and write this in here now. So we're going to say 1, 1, 1, 1, 1, 1, 1, 1. 4. Do the same thing. 1, 2, 3, 4, 5, 6, 7, 8. Group 3. 1, 2, 3, 4, 5, 6, 7, 8. Group 2. And then, of course, the last one, which is 0. 1, 2, 3, 4, 5, 6, 7, 8. This is group 2. And then, of course, lastly, group 1. So now we have all 4 groups in our subnet mask. And again, if you see at the top there where I was explaining the network and the host, your group 4 all the way down to group 2, this is your network. And then here you have your host. So when we look at your network and your host now and we say, okay, well, and this is very interesting now, you're actually gonna like this. How many ones do we have activated for our network? And if we take a look and we say, okay, well, we have 8 of them and we have 3 different groups of them. So now 8 times 3 is what? You guessed it. This is a 24-bit network, or what you'll commonly hear all the time is slash, and this is what you'll hear as far as a prefix. So isn't that cool? A lot of people don't know that when you see a slash and a certain number, that actually tells you what your network is and how many hosts that you have within the network. So in order to break this down even further, right, if we actually were to bring up our screenshot that we captured earlier from our Linux machine. So here is a screenshot that we captured from our Linux machine earlier. And if we actually take a look at what it says there, especially where it says INET4, it actually tells us what our IP address is. And if you see, it says 192.168.1.240/24. That is exactly what I'm talking about. That /24 tells you it's the prefix. The prefix is how many ones are enabled for the network. So of course you add all the ones and you see here 255, 255, 255 is equal to 8 ones in each one of those groups. So it gives you a prefix of /24. So essentially in the Linux world, and which is very different from what you saw in the screenshot of the Windows world, the Linux world, especially from here, shows you a prefix, whereas the Windows shows you a subnet mask. And actually both of them mean the same things and people don't even realize it. So you can figure out what the network is using that prefix. Now, let's switch over to the host side because I think the host is interesting. So if we were to take a look and we say to ourselves, okay, so I know now the network and I know how to calculate the network. Well, how many computers, right? If we look at this little cloud that I drew up here and it says computers 1, 2, and 3, how many hosts can be within that one network? And you guessed it, this last section here tells you exactly how many you can have. So if we look at how many binary digits we have or different combinations, you can see that they are a total of 8 different binary bits. Now they can only be 2 different combinations as we talked about before. They can either be a 0 or they can be a 1. So if we were to do some simple math here, and by the way guys, this is 2, right? And 2 being that it can only be a 0 or a 1, so that's base 2. And we raise it to the 8th power. Why? Because there's a total of 8 bits. What do we get there? Now remember, I'm a big fan of using my tools. I don't need to do all the thinking here. So in case you don't believe me, we can bring up our calculator to help us because of course we're not interested in doing all the work by hand. So with our calculator up, let's go over to scientific. Let's do 2 to the 8th power. And you can see here that that equals 256. So that was actually pretty easy, but just to show you guys, of course, it's 256. So let's go ahead and write here 256. So as you can tell now, we have a total of 256 total computers that can be part of this network, or having the subnet mask of 255, 255, 255.0. Or if you want to look at it in the Linux world, the Linux world gives us a prefix of 24. So that tells us how many bits are for our network. And then the remaining bits is what we can have for hosts, meaning different computers within that network. And again, it's a total of 256. So now that we figured out our hosts and we figured out our network, you can figure out now that 192.168.1, right? This is going to be the network, and then .0, this is where our host starts. And you can do .1, .2, all the way down to 256. All right, guys, so thanks for hanging in there with me. And we just realized that, again, a subnet mask of 255, 255, 255.0, or a prefix of /24, like you're seeing here, gives us a network. And you're seeing the first part of the network there, which is 192.168.1. That is our network. And then, of course, we calculated what the last 8 bits are, and the last 8 bits gives us how many different devices can talk on the network. So you saw 2 to the power of 8. Again, that was a total of 8 bits. So that'll give you 256 total devices that can talk on the network. Now, the last thing that I'll go over with you guys is the fact that actually you really don't have 256 devices that can talk on the network. And now the next question you might be asking is, well, why is it that you can't have 256 devices talk on the network if we just did calculations that show you actually can? And if I were to go ahead and bring this down a little bit and draw over here, remember earlier when I drew this nice little cloud? Let's make this nice and big. Now, remember, the cloud has our whole entire network in here. It's all the devices. So if we were to say computer 1, computer 2, computer 3, and so on and so forth, right? You can go on and on and on. Again, I mentioned 256, but not necessarily, not really. And the reason being is whenever you're calculating networks and figuring out how many hosts you can have, you have to actually remove 2 different addresses. Now, if you're wondering why you have to remove 2 different addresses, is because remember earlier when I said you have this network here? Well, if you have multiple networks, how do you know what network to target? And also as well, how do you know what computer within the network? And so again, you always have to address the network. And so that is where addressing the network, you lose one of the IP addresses here. So for this particular network, if we were to go back up here a little bit, you can see that it's 192.168.1, and then the first address, which is 0, is designated for that network. So as you saw over there, we can go ahead and type, or write, should I say, 192.168.1.0. So the first one and the first IP address is always reserved for the network. So that way we know the network that we're targeting. Now remember, that is one of the 2 IP addresses that you're going to lose whenever you're calculating your network. Now the other one that you're going to lose, and this one is interesting, is called the broadcast address. I'll put a network here because, again, all zeros, if you translate your binary zeros, all 8 of them into zeros, that of course gives you that 0 that I talked about up there. Now, if we were to take the last octet, which is this guy here, and we were to do 1, 2, 3, 4, 5, 6, 7, 8, that is 8 ones, right? What does that turn into? And again, use a calculator to help you out. The calculator is your best friend. So if we were to actually take a look at binary ones, right, all 8 of them in decimal, that is 255. So let's go ahead and write 255 here. And 255 is your, and we can say broadcast. So essentially what the broadcast is in a nutshell, if I want to communicate with all the machines on the network at the same exact time, let's say I want to send a piece of information to computer 1, computer 2, computer 3, and I want to send it all at the same time, and let's say, for example, maybe there's 100 computers, I can actually send a message to 192.168.1.255. That is our broadcast, and it will go ahead and send that information out to all the computers at the same time instead of sending all of these different informations individually to every single 100 computers. And that is a cool way in order to address all the machines and bring down how much network traffic we have in our network, which is really, really cool. So remember, you always lose those two addresses, which is the first one, the network, and then of course the last one, which is 255. So for those of you who are saying, hey, I had a total of 256 different addresses, but you only have 255 listed on there, how come you don't have a 256 as the last one? Well, keep in mind, guys, zero, remember zero counts as one. 0 to 255 is equal to a total of 256 different addresses. So that is why you have 255 as the last one, all ones, instead of having 256. For those who didn't catch that real quickly, right? You always have to count that zero. That zero is a one, meaning it counts as one address. You don't, say it doesn't exist. So that is pretty cool there. Now here's the last thing that I will say, and thank you for staying with me this long. The last one that I will bring up, because I promised you guys that I would teach you, if we go back here, you've learned what an IPv4 address is. You learned what a subnet mask is. The last thing is your default gateway. What is that? And this is, of course, on the Windows side. Now, if we look on the Linux side, again, you learn the same exact thing. Here is your IP address. Here's your subnet mask. The last thing that I didn't talk about is the route for default via 192.168.1.1. I didn't talk about that, which is, again, the default gateway. What is a default gateway? So the default gateway essentially is your router, right? Whenever you are sending your information over and you're trying to route within your home network, your address for your network is 192.168.1.0. This is going to be our network. Now, if we were to take a look at the next IP address, we have 192.168.1.1. This is going to be our router. If I were to go for my IP addresses and say, hey, here's a whole list, right? We can do essentially, if we go down the list here, 192.168.1. And remember, we have now, this can be 2 all the way down to 254. And remember, the last one, 192.168.1.255, this is equal to our broadcast. And we talked already about what a broadcast is. So now, essentially, I can have any laptop, any cell phone, any streaming devices, anything in my house that has to talk to the outside world. That is between IP addresses 2 and 254. And why is that again? Because 0 is our network, 1 is our default gateway, which is our router, and 255 is our broadcast, meaning I want to send information out to everybody. So if I were to take a look up here now and take a look at the screenshots, well, remember, we can go up to from 2 to 254. So in our Linux machine, we had 240. That is a valid address. And in our Windows machine, we had a 49. And that is also a valid address. So now at this point, you now know what an IPv4 address is. You now know that you have a subnet mask, and you see what that is, 255, 255, 255.0, or in the Linux world, as you saw, you have a prefix of 24. So you now know what a subnet mask is, what a prefix is, and lastly, of course, you learned about the default gateway, which is, of course, the router. Where do you need to send your information to in order to be able to send it to other places in the network? Because again, your router, and that's why it's called a router, does the routing for you. Now, here's the last thing that I'll leave you guys with before heading out. And I want you guys to think about this and let me know in the comments section below what your thoughts are. So if you learned all about an IPv4 address and you learned all this good information, let me bring up a browser for you. So Google tells us that there's 8 billion people in the world, but we just realized that an IPv4 address is only 32 bits. So how many possible IP addresses do we have? So if we do a little bit of math here, remember 2, because it can only be a 0 or 1, that's our base. And let's go to the power of 32, which means that we have about 4.2, well, 4.3 if we want to round up, 4.3 billion IP addresses. So here's the thing now, and I want you guys to comment in the comment section below now. If there's only 4.3 billion IP addresses and 8 billion people in the world, and let's say everybody in the world had one device, it sounds to me like we're going to run into a big issue. There's not enough IP addresses for everybody to be able to communicate on a network, right? So welcome back, guys. By now, you should all be experts in IPv4 addressing. So you should know all about what an IPv4 address is and how to calculate that. You should know also about subnet mask and prefix. And by the way, they're the same thing once you start calculating it. And also as well, you have a very good understanding of what a default gateway is. Now, as I mentioned in the video, I'm curious to hear your thoughts on how we solve our IPv4 challenge. So leave your comments in the comment section below. So there's a lot of great things that we covered in this video. So guys, if anything confused you, make sure you watch it over and over again, because again, it took me a little bit to figure all this stuff out. So practice makes perfect. And as always, guys, I love you and I appreciate you all. Thanks for being here with me. And if this video has provided value, go ahead and give me a like for the video as it helps the channel grow. Make sure you subscribe to the channel and turn on your notifications so that way you're notified when I upload new videos to the channel. And lastly, of course, share this with a family member or a friend. Oh, and one last thing, guys. If you don't want to wait for my next video, YouTube thinks that you'll like this video popping up on screen. So go ahead and check that video out, and I'll see you all in the next one.